Station Houston, are you ready for the event? Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
We have you loud and clear.
Please stand by for opening remarks.
Good morning. I'm Corey Alderdice, Director of the Arkansas School for Mathematics, Sciences, and the Arts, located in Hot Springs National Park, Arkansas. It's the start of a new year at ASMSA, and we're honored to have the opportunity to participate in today's NASA downlink with astronauts aboard the International Space Station. At ASMSA, we're igniting Arkansas's potential. Our students' curiosity knows no bounds. So let's get started with our first question.
My name is Karis Flood, and I'm a junior, and my question is, if you could add something to the International Space Station, what would it be and why?
Well, there's a couple things I can think of right off the bat. One is more windows, because it's really incredible looking out at our beautiful planet. We have a lot of crew members up here now, and there's only a couple windows, so we kind of got to share that a little more than probably we would like sometimes. Another thing is a shower. So if you guys can figure out how to make a shower for us, we would love to have one of those up here.
Hi, my name is Zurnum Deb and I'm a senior. My question is, what is the most surprising physical feat that you've been able to accomplish on the space station that you couldn't do on the ground?
I can tell you on the ground I can't even do a single backflip, and right now, for the first time, I'm about to attempt a triple. So here we go.
And he stuck the landing. That was pretty impressive.
Hi, my name is Isabella McCoy and I'm a junior. My question is, have you ever seen any major damage taken by the station?
You know, we don't see a whole lot of that, although I looked out the window a few days ago when I was taking pictures of something else, and I saw one of our radiators has a big tear in it. So to me, that's the biggest damage that I've seen on the International Space Station.
Hi, my name is Caitlin Valdez. I'm a junior. My question is, how does microgravity affect the way you sleep?
Well, from my personal experience, when I first got here, trying to sleep where it feels like you're falling was not comfortable. But now it feels like the most comfortable mattress you could possibly have. Floating in space is a wonderful way for me to sleep. And I expect when I return home to have a hard time sleeping because adjusting to home.
Hi, my name is Danielle Lewitt, and I'm in the 12th grade, and my question is, what is the hardest part of becoming an astronaut?
Wow, when I was trying to become an astronaut a while ago, people always told me the hardest part is just get to the interview stage of the whole process. And that's pretty true, I think. I mean, if you could, there's thousands and thousands of people that apply to be astronauts every time there's a selection. And if you can get in the interview group, that's about the top 100 to 120 or so. And so that kind of proved to be true. But once I got in that group, then I was like, wow, what am I doing with these 100 people? Because they were absolutely incredible people, and I felt like I didn't have the skills to be in that group. But fortunately, I got selected.
Hi, my name is Sabina Day, and I'm a junior. My question is, what would you recommend a high school student to do in order to pursue a career at NASA?
That's a fantastic question. I think you should figure out what you're really passionate about and then work really hard at doing your best at everything, the things you're passionate about and everything else you have to do. And then make little decisions like express your curiosity in NASA, listen to lectures about it, get on the internet and research internship opportunities. Just make lots of little decisions that might eventually involve you finding an opportunity to work at NASA. There's all kinds of jobs there.
Hi, my name is Sheridan Deathrow, and I'm a senior, and my question for you is, how has your previous career prepared you for life in space?
Well, Mark and I both were previous Army officers, and I was a pilot in the Army So there's lots of skills that have transferred over. I mean, and a lot of the similar things that we had, even though I was a pilot, he was an engineer officer. But just, learning how to work as a team, learning how to work in really austere environments, not needing a lot of things to survive. Our operational experience, I think, really plays well for us here at NASA, where we know how to run checklists, we're disciplined, and we know how to be leaders, and we know how to be followers whenever the time is right. So all those traits have really carried over from the Army to make us, I think, better astronauts.
Hi, my name is Natalie, and I'm a junior. My question is, what is the most interesting experiment you have conducted or have seen conducted while on the space station?
About a month or two ago, I got to participate in an experiment called celestial immunity. One of the nice things about the space station is since everything is in a free fall together, you can do experiments on cells that aren't in the human body, better simulating that they are in a body. So we were able to do experiments on donated cells and test the immune responses in the space station.
Hi, my name is Lilia Adams, and I'm a junior. My question is, what is your favorite memory made while at the space station, and why?
We've had a couple of recent memories that have really stuck in my mind, and that's the first, about a week or maybe 10 days ago now, we had our first real aurora sighting up here for the whole crew. And so once we saw it out the window, we all started yelling, and then we all had that memory together of watching it for about 10 to 15 minutes. So that was pretty special. Another special memory with all of our crew together was just about a week ago, we had pizza night. So we had a cargo spacecraft that showed up last week, and it actually brought pizza kits for us, which is very unusual in space. And we got to enjoy our own homemade pizzas together. So that was a great memory.
Hi. My name's John Bray, and I'm a senior. And my question is, what camera settings, lens, and filters do you use to take good pictures of the Earth given the high speed of the space station?
One of the big things we got to do is pay attention to the window we're looking at, because the optical quality of the window makes a big difference. But I just happen to have one of our best cameras up here. Shane's actually incredibly good at aiming at things on the Earth to use this camera. This is a doubler, I believe, with an 800 millimeter lens. As far as settings go, lately, I don't know if this really works, but my latest theory is if I put the ISO to be equal to at least as high as the camera, the focal length of the lens, then that enhances my chances of being successful. And then I'm experimenting with doing a shutter priority and setting the shutter speed to 1 over about the length of the lens, the focal length of the lens as well. Again, I'm still learning, so that's a work in progress, trying to figure out if that really, really works.
Hi, my name is Danielle Lewitt, and I am in the 12th grade. And my question is, how do you defend against space debris during the station's orbit around the Earth?
Well, thank goodness we have a lot of people on the ground in the mission control centers and other people around the United States that are watching out for big debris that's maybe in our orbit. We don't have a lot of things in our orbit, actually around the 250-mile mark, thank goodness. But the pieces that are out there, we have people that are tracking those. And if they say we're going to come into maybe a 200-kilometer sphere of that object, then we have a couple things we can do. The ground controllers in Houston can actually move the space station out of the way. They can work with the other control centers around the world to make sure we do that safely. And so that's been done before. If we find out about an object pretty late in the game, then they'll send us to either our spacecraft, in my case to the SpaceX Dragon, in Mark's case to the Russian Soyuz, and we'll just shelter in place there. And if something happens, then we'll be in our return vehicle to be able to depart and come home and stay safe. And if not, and it's not going to be that big a deal, sometimes they'll just put us in a safer part of the International Space Station.
Hi, my name is Micah Brown, and I'm a senior. My question is, what are some of the current strategies being implemented on the space station to try and diversify diets and combat menu fatigue in astronauts?
Gosh, I think we're being really successful. In a way to answer this question, I'm going to show you evidence of some of the things we've got. We've got thermal stabilized food. This one is one of my favorites, tropical fruit salad. It's like canned fruit in a bag. I'm just going to let that free float for a while. Why not? Then we've got things like, what do I have here? I got spicy green beans. These are actually delicious. There's spicy green beans. You put in 75 milliliters of hot water, let it sit for 5 to 10 minutes, and you got some really good spicy green beans. Not everything in these packages is rehydratable. This is dried. It's dried pears, also very good. Thanks for the support. And then mango salad. Not everything has fruit in it, but it sure tastes good when it does. This one's a mango salad. Again, it's rehydratable, 50 milliliters of cold water, not hot water. Although we don't get cold water, we really get ambient water. We do have a refrigerator we can put things in. And then this is an example of a drink bag. One of my favorites is orange juice. So we add 250 milliliters of ambient water to this and wait a while, let it dissolve, and you got some orange juice that you can drink out of a straw. Thanks for the question.
Hi, my name is Nasha, and I'm a sophomore. My question is, are you allowed to bring personal items with you to space?
We are allowed to bring personal items. We have a little bag. It's a little suitcase-looking thing, maybe about this big. I'm showing you that we can bring personal items. And so that can range from anything from T-shirts from maybe a university you went to little things from your families to pictures. You name it. You can pretty much put most things in there. And we all pretty much fill that up because we want to kind of return special favors to organizations that we belong to or bring up something special for our family and friends.
My name is Alan Dodd. I'm a teacher. My question is, what kinds of sustainability-related or environmentally focused experiments are you running up there that may inform our understanding of systems here on Earth?
Well, one of them is water recycling. We recycle, like, if I remember correctly, about 95%. Maybe we're getting up to 98% of our water resources on board the station, and you can imagine all the varieties of water we have on the space station. And then also, like for example today, one of the ways we support the Earth is sometimes with just photography, doing crew observations of the Earth. There's flooding that we've been taking pictures of, and also fires we've been taking pictures of lately to help people understand the situations on the ground.
Hi, my name is Sean and I'm a senior. My question is, what kind of vibration isolation systems are employed to avoid movement inside the station from affecting its orbit around the Earth?
Thanks for the question, Sean. The ones that are most familiar to me are the ones that are on our exercise equipment. So we have a resistive machine where we do our weightlifting, so to speak, and then we have a treadmill and a bike that we do our cardio on. And all those systems are pretty much floating. They're on isolation systems because you can just imagine if Mark here was doing a 400-pound squat and it was actually bolted to the structure, it would definitely cause some vertebrations in the and vibrations in the solar arrays out on the end. So we don't want to do that. We don't want to put any extra force into the structure of the space stations. And so those kind of things are on isolation systems to protect the integrity of the space station.
Hello, my name is Patriciana Krakowiak-Valdivia, and I am a genetics teacher. And my question is if there are any polymerase chain reaction or PCR tests that are continuing to be done on the station right now to see how replication and repair of DNA are affected by weightlessness.
So we have a continuing program. I'm not sure if in the moment we're actively doing it right now, but I know Genes in Space is a continuing program where high school students can provide inputs into experiments we do on the space station. And I've seen some incredible presentations by really remarkable students telling me what they learned. Also, we're in our 5th year of doing genes in space, genetic research in space. So it's a very promising field up here.
My name is Eric Aravet. I am a student success coordinator, and my question is, does weightlessness affect animal behavior?
So a lot of researchers are interested in that, and so we get to see sometimes very small organisms up to some types of animals sometimes because of their biology. And their biology simulates human biology, and so that's what the researchers want to see, and maybe learn something from those kind of organisms and other small creatures that we can relate to humans and protect our safety down the road. So we've had a few of those on board this time on this mission, and I think on my last mission I had several as well, and Mark probably did too. So another ongoing investigation thing where we're looking at small animals or organisms that can relate to humans.
Hi, my name is Nasha and I'm a sophomore. My question is, do you have better Wi-Fi in space than you do at home?
Fortunately for me, when I'm at home, I have better Wi-Fi there. Wi-Fi is quite good up here now compared to my last flight as far as my ability to get to the same internet resources that you have available on the ground. We have a very, very supportive system up here for that. But we have a completely separate system for all the science we're using, and that works very well as well.
Hello, my name is Dina Hughes, and I am an alumna of this school. I also work in admissions. And my question is, how do fluids that are thicker than water behave in space?
Well, that's something we're really interested in for a couple applications. One is fuel. So if you imagine fuel, like our fuel tanks on our spacecraft, if the fuel's sloshing around and maybe not hitting the fuel pump head, it could possibly cavitate. So we want to understand how that behaves, and we've been working on this for a couple years now. Not we, but scientists and researchers. We've gotten to do some of the experiments to help out with that, to make sure that we can understand how fuels operate, to make sure we get fuel every time we need to fire our jets, maybe as a spacecraft is approaching the space station, for example. Another thing we've been doing, and we have done on this mission, is plant water management is a nice experiment we've been working on, where we're looking at the flow of something a little thicker than water. In our case, we use tropical punch, believe it or not. But the scientists and researchers want to see different hydroponic techniques of watering plants. And that's going to help us as we grow plants on the International Space Station or in space in general. And hopefully some of those techniques can also help people on Earth.
To our ASMSA students and colleagues, as well as everyone watching online and via NASA TV, thanks for joining us for today's Downlink. Be safe, stay well. Here's to a great year of learning ahead.
Station, this is Houston ACR. That concludes the event.
And thank you all participants. Station, we're now resuming operational comm.